Our universe is vast. It stretches beyond our wildest imaginations, encompassing distances and scales that are almost impossible to comprehend. It's filled with billions of galaxies, each teeming with billions of stars. These stars form intricate patterns and clusters, creating a cosmic dance that has been ongoing for billions of years. But what if our universe isn't the only one? What if beyond the vast expanse of our cosmos lies an even greater reality? What if there are countless other universes, each with its own unique laws of physics, constants, and even realities? These universes could be vastly different from our own, with their own unique forms of matter and energy. This is the mind-boggling concept of the multiverse, a theory that suggests our universe is just one of many, a realm of possibilities that stretches the boundaries of our imagination. The multiverse concept invites us to think beyond the confines of our known universe and consider the infinite possibilities that lie beyond. The idea of a multiverse arises from cutting-edge theories in physics and cosmology. These theories, such as string theory and quantum mechanics, suggest that our universe may be just one of many in a vast multiverse. These theories attempt to explain the fundamental nature of our universe and its origins. The Big Bang Theory, for example, posits that our universe began as a singularity and has been expanding ever since. While still speculative, the concept of a multiverse has captivated scientists and the public alike. Researchers are constantly exploring new ways to test these theories and uncover evidence of other universes. It raises profound questions about our place in the grand scheme of existence. Are we alone in the universe, or are there other forms of life out there? What does it mean to exist in a multiverse? Imagine a reality where you made different choices, where every decision you made created a new universe with its own unique timeline. A universe where time flows differently, where the past, present, and future are not linear but interconnected in ways we can't yet understand, or even a universe governed by entirely different forces. These forces could create worlds that are completely alien to us, with their own unique forms of life and matter. The multiverse, in its essence, encompasses this staggering diversity. It challenges us to expand our definition of reality and consider the possibility that our universe is just one of many in a grand cosmic tapestry. It challenges us to expand our definition of reality and confront the possibility that our universe is just one of many in a grand cosmic tapestry. The multiverse concept pushes the boundaries of our understanding and invites us to explore the infinite possibilities that lie beyond our own universe. The story of the multiverse begins with the Big Bang, the event that brought our universe into existence. In the first fraction of a second after the Big Bang, our universe underwent a period of rapid expansion known as cosmic inflation. This exponential growth spurt stretched the fabric of space-time, smoothing out its initial wrinkles and setting the stage for the universe we observe today. But what if cosmic inflation didn't end everywhere at the same time? This is where the concept of eternal inflation comes into play. Eternal inflation suggests that while inflation ended in our region of space-time, it continued elsewhere, potentially giving rise to other universes. Imagine blowing bubbles into a soapy bath. Each bubble represents a universe expanding outwards from its own Big Bang event. Some bubbles might be similar to our own, while others could be radically different, governed by different physical laws and constants. This is the essence of the multiverse predicted by eternal inflation. The concept of eternal inflation paints a picture of a multiverse as a vast and ever-expanding landscape of bubble universes. These universes emerge from the quantum foam, a seething sea of quantum fluctuations that permeates the fabric of space-time. Like bubbles forming and popping in a pot of boiling water, universes are constantly being born and expanding within this multiverse. Each bubble universe within this multiverse would be causally disconnected from our own. This means that we would be unable to observe them directly or interact with them in any way. The vast distances between these universes, coupled with the rapid expansion of space-time itself, would create an insurmountable barrier between them. However, the existence of a multiverse predicted by eternal inflation would have profound implications for our understanding of the universe. It would suggest that the physical laws and constants we observe in our universe may not be universal but rather local to our own cosmic bubble. Section 4. The Many Worlds Interpretation. A Quantum Perspective. While eternal inflation offers a compelling vision of a multiverse arising from the early universe, it is not the only theory that suggests the existence of multiple universes. Another fascinating approach comes from the realm of quantum mechanics. The many worlds interpretation, or MWI, approaches the concept from a completely different angle: quantum mechanics. This interpretation was first proposed by physicist Hugh Everett in 1957 and has since sparked both intrigue and debate within the scientific community. Quantum mechanics is a branch of physics that governs the behavior of matter and energy at the atomic and subatomic levels. It is a field that has revolutionized our understanding of the universe, revealing a world that is both strange and wondrous. One of the most perplexing aspects of quantum mechanics is the concept of superposition, where particles can exist in multiple states simultaneously until a measurement is made. This idea challenges our classical understanding of reality. In the quantum realm, particles such as electrons and photons can be in a state of superposition, existing in multiple places or states at once. This phenomenon is not just theoretical, it has been observed in numerous experiments. The act of measurement, according to the MWI, doesn't collapse the wave function into a single outcome as traditionally thought. Instead, it suggests that all possible outcomes of a quantum measurement actually occur, but in separate parallel universes. This means that every time a quantum event happens, the universe splits into multiple parallel universes, each representing a different possible outcome. This idea is both mind-boggling and profound. Imagine flipping a coin. In our everyday experience, the coin will land on either heads or tails. However, according to the MWI, both outcomes occur, just in different universes. In one universe, the coin lands on heads, while in another, it lands on tails. This branching process happens for every quantum event, leading to a constantly diverging network of parallel realities. But the implications of the MWI go far beyond simple coin flips. Every decision we make, every interaction at the quantum level, creates new branches in the multiverse. This means that there are countless versions of ourselves living out different possibilities. Every quantum measurement or interaction creates a new branch in the multiverse, leading to an unimaginably vast and constantly diverging network of parallel realities. This network is so vast that it is beyond human comprehension. The many worlds interpretation challenges our understanding of reality and forces us to reconsider the nature of existence itself. It suggests that the universe is far more complex and interconnected than we can possibly imagine. As we continue to explore the mysteries of quantum mechanics, the MWI remains a powerful and thought-provoking perspective on the nature of the cosmos. Section 5. Searching for echoes in the cosmic microwave background. The idea of a multiverse, while fascinating, remains a theoretical construct. To move from the realm of speculation to scientific acceptance, we need evidence. One avenue where scientists are searching for clues is the cosmic microwave background, or CMB. The CMB is the faint afterglow of the Big Bang, a thermal radiation that permeates the universe. It carries imprints of the early universe, like a cosmic fingerprint. Scientists believe that if our universe collided with another universe in the distant past, it might have left subtle patterns or anomalies in the CMB. These collisions, if they occurred, would have released tremendous amounts of energy, creating ripples and temperature fluctuations in the CMB. While no conclusive evidence of such collisions has been found yet, the search continues with increasingly powerful telescopes and sophisticated data analysis techniques. Section 6. The nature of reality. Navigating the multiverse landscape. The concept of a multiverse challenges our fundamental understanding of reality. It suggests that what we perceive as the entirety of existence is merely a fraction of a much grander, more complex system. It forces us to confront the possibility that our universe, with its familiar laws of physics and vast cosmic structures, is just one of many possible realities. Each of these realities could operate under different principles with unique physical laws and constants. This can be a daunting concept, but it also opens up a world of wonder and possibilities. Imagine the potential for discovery, the endless realms of knowledge waiting to be uncovered. If the multiverse exists, it means that the range of possibilities for life, for intelligence, and for civilizations is far greater than we ever imagined. There could be countless forms of life, each adapted to their unique universe. There could be universes where the laws of physics are tweaked in ways that allow for forms of life we can't even begin to comprehend. These life forms might have evolved in environments so alien to us that they defy our current understanding of biology and physics. The multiverse also raises profound philosophical questions about the nature of identity, free will, and the meaning of existence. If there are infinite versions of ourselves, each making different choices, what does that say about our sense of self? If every quantum measurement or decision creates a new branch in the multiverse, what does it mean for our choices and actions in this reality? Are we truly in control of our destiny, or are we just one of many possible outcomes? Do they hold any significance in the grand tapestry of the multiverse, or are they just fleeting moments in an endless sea of possibilities? The multiverse theory invites us to ponder these deep questions and consider our place in the cosmos. As we delve deeper into the multiverse theory, we also explore the potential for travel between these universes. Concepts like wormholes and cosmic strings could theoretically connect different realities, offering pathways to entirely new worlds. The implications for technology and exploration are staggering. Advanced civilizations might have already mastered the art of traversing the multiverse, unlocking secrets and knowledge beyond our wildest dreams. Ultimately, the multiverse theory challenges us to expand our minds and embrace the unknown. It encourages us to question our assumptions and explore the infinite possibilities that lie beyond our current understanding. As we navigate the multiverse landscape, we embark on a journey of discovery, wonder, and profound reflection. The nature of reality is far more intricate and awe-inspiring than we ever imagined.